Yes. In this class, we will discuss about one of the continuous probability distribution, which is normal distribution. So, which is mostly used in many practical problems. So, in this case, this probability density function of a normal distribution PDF is defined like this: f of x is equal to 1 over sigma root 2 pi into e to the power of minus of x minus p whole square divided by 2 sigma square. So you can see that this is a continuous function. So this is a continuous function. So that is why this distribution is known as continuous probability distribution. So earlier classes I had explained about Poisson and binomial distribution. They are discrete probability distribution because they were not having any functions. So they were defined in terms of some numbers, NCR, p power x into q power n minus x, like that in binomial distribution. And in the case of Poisson distribution, it was defined in terms of m and e. So here, if you observe, this is a function. This is a function of x. So if you go on give the values of x, you will get different values of this function. And the condition is here, this x value can vary from minus infinity to plus infinity. That means it can be any real number, negative or positive real number. And mu also can vary from minus infinity to plus infinity. And the sigma, that is standard deviation, is greater than 0. That means it is positive. Standard deviation is positive. So this is the condition. And another thing is, if you integrate this f of x, this function f of x, between the limits minus infinity to plus infinity, you are going to get 1. So that is another property of normal distribution. This is the PDF, probability density function. This is the property of the probability density function. Now if you find out the mean and standard deviation for a normal distribution, it is given by, mean is given by mu only, mu is this value, and sigma is the standard deviation. That means for any data, set of data, if it fits any distribution, the normal distribution also has the same mean and standard deviation value. If you plot a graph of this f of x, see here, f of x is a function of x here. If you plot a graph of f of x versus x, you are going to get a curve like this. This curve is a bell-shaped curve. It is like a bell-shaped curve. And another thing is, it is symmetrical about x is equal to mu line. X is equal to mu. Suppose if you take a x is equal to mu line here, it is symmetrical. That means left half of the curve is equal to right half of the curve. That means if the area, if the total area under the curve is 1, then area to the left of this x is equal to mu will be half. Area to the right of this x is equal to mu will be half. So this curve is called as normal probability curve. So f of x, this can be plotted on a graph sheet like this. So it will give a bell-shaped curve which is symmetrical about the line x is equal to mu. So this is the property of normal distribution. It is a continuous function. In that special case is standard normal distribution. So if you want to have standard normal distribution, we will speak in terms of probability. Suppose if you want to find the probability of x which lies between a and b. So since these types of problems we have done earlier, which lies x lies between two values a and b, then what happens here, that is given by this function itself, but you have to integrate between a and b. So that will be given by 1 over sigma root 2 pi, it is same, into e to the power of minus of x minus q whole square by 2 sigma square. But this integration we have to take between a and b. If two finite values, for example, that means here, if you take two values here, z1, if you take two values here, I will take this as a and b like this. This is x is equal to a, this is x is equal to b. You are integrated between these two values. That is the meaning. So now to integrate this, it becomes tedious. That means it is very difficult to integrate a complex function. So that is why, of course, you can do using numerical integration technique. Even then it is tedious. So therefore, we will have a substitute like this. I will take another variant which is called as standard normal variant, SNV. Standard normal variant, SNV. Z is equal to x minus mu divided by sigma. I am going to substitute Z as x minus mu divided by sigma, where mu is the mean of the distribution, sigma is the standard deviation of the distribution. If you take this substitution, then if you cross multiply, x minus mu is equal to sigma into z, or you can take x is equal to mu plus sigma into z. If you differentiate that, you are going to get dx is equal to differentiation of mu is 0 because it is constant, mean value is constant, z is variable here. So sigma into z, differentiation is sigma into dz. Now what I can do here is, what the corresponding value of z at x is equal to a. So this is x is equal to a, Here the value of z is z1. At x is equal to b, the value of z is z2. Okay. So z1 is in the place of x you have to put a. So z1 is equal to a minus mu by sigma. Here mu and sigma are constants. And z2 is x is equal to b, you have to take b minus mu by sigma. I am changing x to z, that's all. I am transforming a variable x to z. So this value z1 corresponds to x is equal to a, z2 corresponds to x is equal to b. Now this probability, now we can write like this: p a less than or equal to x less than or equal to b is same as p z1 less than or equal to z less than or equal to z2. So x is equal to a is replaced by z is equal to z1, x is equal to b is replaced by z is equal to z2, and x is replaced by z. Okay. Now this can be written like this. So I have taken this x minus mu by sigma as z, So in this, so you can see here this x minus mu whole square divided by here sigma square is there. So if you take the square root of this, or you can write like this: x minus mu by sigma whole square. Correct? You can write like this. And this I have taken as z. Therefore, it becomes z square. So here this x minus mu whole square by sigma square can be written as z square. So then, therefore, what happens to this? So here 1 by root 2 pi is there here. Root 2 pi is there into integral z1 to z2. Here it becomes e to the power of minus z square. This becomes z square. You can see x minus whole square by sigma square can be z square divided by 2 in there. And this dx is nothing but sigma into dz. So if you put this dx as sigma into dz, what happens? This sigma and sigma will get cancelled. Correct? This sigma and this sigma will get cancelled. So you will be left with only dz. So this is another form of writing the same thing. So what I am doing is I am changing x is equal to a to z is equal to z1, x is equal to b to z is equal to z2. So x will be changed to z, a will be changed to z1, b will be changed to z2 by using this substitution. So this distribution is called as standard normal distribution. That means this I can write it as like this. Like this if you write. So here it is 1 by sigma root 2 pi. Here the sigma will get cancelled. 1 by root 2 pi into e to the power of minus z square by 2 is 0. This is called as standard normal probability density function. This is normal probability density function. This is standard normal PDF. So that is in terms of z if you write, it is standard normal. In terms of x if you write, it is normal. Okay. Now the one important property is that the mean of this standard normal PDF is 0. Whereas the mean of this normal distribution is mu. Correct? Mean of normal distribution is mu, Mean of standard normal distribution is 0. Similarly, standard deviation of normal distribution is sigma, whereas standard deviation of standard normal distribution is 1. So we are normalizing it. So 0 and 1. So you have to remember that for a standard normal distribution, mean value is 0 and standard deviation value is 1, whereas for normal distribution, mean value is mu and standard deviation is sigma. So if you transfer this graph in terms of z, it will be like this. The same graph f of x will be transformed in terms of z like this. This is also bell shaped, this is also symmetrical, but only thing is this is symmetrical about this line. This line is z is equal to 0. Z is equal to 0 along this line, is it not? So this is a bell shaped thing. So instead of taking x is equal to a, I will take z is equal to z1. Instead of taking x is equal to b, I will take z is equal to z2. So the area on this function I will take it as phi of z. The area between these two ordinates is tabulated in a tabular form. It is given in the table. So we can directly refer the table. So what happens here? This is a standard normal curve which is symmetrical about z is equal to 0. Here this is a normal distribution curve symmetrical about x is equal to mu. This is a standard normal curve symmetrical about z is equal to 0. After transformation, we have it like this. The area between any two ordinates is given by this line. That is your probability. So probability is directly given by the area under the curve. So which you can read directly from the table. That is the advantage of going for standard normal distribution curve. So in this case, if z1 is taken as 0 and z2 is z. If z1 is 0 means I am taking z1 here and z2 is z here. So it is like this. Okay, z1 I am taking 0, z2 I am taking z. So then only this area you have to take, correct? Only this much area. So these are the values which are tabulated for positive values of z. Positive values of z, right? You have to see to the right side of this line. Right side of this line. So the meaning of this is called as normal probability table. How to read I will tell you. Suppose if the z value is, I will take 1 point. If z value is 1.12, then what is the value of area or the phi of z? Phi of z value from this table, how to read? I will tell you. Z is how much? 1.12. So you read like this along the column. So 1 is here, 1 is here, 1.1 is here. Here horizontally also 0, 1, 2, 3, 4 will be there. So if you want for 1.12, so you have to see in the column, z column for 1.1, then here 2 we have to take. So this is actually 1.12. The value of phi of z is this, 0.3686. Like this we have to read, okay? Like this we have to read. So this area, suppose if this z is 1.12, if this is 0, the area between these two ordinates is this much. The total area of the curve is 1. From the total area from here to here, it is 1 area under the curve. In that, if you are taking 1.12, z dash 1.12, between 0 and z, the area is 0.3686. Similarly, I will take one more value. Let me take z is equal to 0.21. 0.21. What is the value of phi of z from the table? So I think z is equal to 0.21, you know. So z is equal to 0.21 means this is 0.2 and this is 1. So you have to take this one. So this is z is equal to 0.21. Second decimal place you have to take in the row. First decimal place you have to take in the column. So phi of z will be 0.08. But that means if z is here, suppose if z is here, if this value of z is 0.21, if z is 0.21, the area will be this and this area, okay? That is 0.0832. So the area increases as you move further. So please note that this curve is asymptotic to z-axis. Asymptotic ಅಂದ್ರೆ ಏನು? It will not touch. Finally, it becomes parallel to the curve. That is called as asymptotic curve. Asymptotic means it won't touch this line, but it will be parallel to the curve. ಹಿಂಗೆ ಹೋಗುತ್ತೆ. This is called as asymptotic curve. It won't touch us, but it seems it will touch us, but it will never touch. It is not a closed curve. It is a open curve. So it seems to be touching, but exactly it will not be touching. So it is asymptotic curve to z-axis. So this is the fundamental concept of normal distribution and standard normal distribution. So here this normal distribution you can use when n is large, when the number of readings records are more, then you can go for normal distribution. So in most of the cases, for example, the marks of some 1,000 students, it will fit. You can fit a normal distribution curve for that. When n is large in terms of hundreds, thousands, so then you can go for normal distribution. So next class I will take up some problems on normal distribution.